Okay, we're almost getting done with this section, which is good. Our book at this point wants to remind us of what the arc length formula is. We can remember the arc length formula. I would say 9 times out of 10 we don't have to. Well, the idea when you're looking at it basically says, look, if you're on the unit circle, the arc length is exactly what we mean by the angle measure. If you're on a circle, for example, that's twice as big, the arc length winds up being twice as big as well. And that's actually what this little formula right here says. It says the arc length is just how much bigger the new circle is than the unit circle. So if the radius is twice as big, the arc length is twice as big, etc. Now, if I want to start using this in solving problems, I don't like using the arc length formula because it says, hey, start doing problems differently than you did before. So I want to show you how I would do the problem as just an extension of what we were doing before. So what I have, you can see I have what I have before, but I've just added one thing. I know that 1 lap is exactly the same as 360 degrees, is exactly the same as a distance of 2 pi around the unit circle, is exactly equal to the circumference around a big circle. So that's 1 lap, and that's 1 lap, and that's 1 lap, and that's 1 lap. And we can just use that every time we do these problems, and I don't have to remember the arc length formula, which I'm happy about. So here's an example. It says an arc length of a circle of radius 4.7 feet is cut out by an angle of theta equals 100 degrees. And what I'd like to do is convert this to arc length first. Convert. And they tend to use the letter S for length. That's a physics thing. Yeah, every time you see S after this, it's always going to be physics. It's always going to be position. Anyways, what am I going to do? I'm just going to start out with 100 degrees. And I want to do the same thing I did before. I just want to multiply by a fraction. The degrees have to go away, so the degrees have to be down here. I'm going to put 360 degrees. Now I know they want a distance. What I want of these 4 things, the only one that's distance around a big circle is the last one. So I'm just going to put a 2 and a pi, and then the radius of the circle, and I'll include the units, 4.7 feet, like that. You can see the degrees cancel like that. I'm not going to do any of the arithmetic. I just want to get this done. If I get 200 times 47, I think that's actually 940 pi on top, divided by 360 on the bottom, and that should be feet. I don't think that's very many feet, but that's it. We actually just took the degrees, we multiplied by the right kind of fraction that got rid of the degrees and put the feet in, and we get feet for an answer. If they ask us to do any of the other things, well, we've actually done this before, but here's just one example. We could try to convert that to radians. Convert to radians, like that. And I'm going to start out with my 100 degrees like I did before. I want to multiply by a fraction that gets rid of the degrees and puts radians on top. So 1 lap is 360 degrees, so I put that down here. 1 lap around the unit circle is just 2 pi. And I get like that. The degrees cancel like this, and what we're going to get is 200 pi over 360, and that's in radians. And all that says is we would want to go that distance around the unit circle to actually get to the point that we're at. So the nice thing about this is if you can just remember this thing on top, and those are all formulas that you've seen for a long time, you don't have to remember or even use the arc length formula. So it's one less thing to remember.